This is 2007 Form A, number 3, Part B. So they give us a lot of information. So you have a particle. Let me erase this stuff from the last problem. So you have a particle moving along this. So it's kind of cruising along, going along this curve like that. That's what it's saying. It's moving about this curve. And it starts at an angle of 0. That's the starting point right here. This particle moves along the curve, so dr dt equals dr d theta. So how do you interpret this? That's going to require some chain rule for us, but basically theta is time. So instead of thinking, okay, theta 0, theta 1, theta 2, time is moving. So basically, as time goes on, it's moving around the curve, and each angle represents the time that occurs. So that's all the statement is saying, but we're going to have to deal with that with chain rule, I believe. They want to find dr dt. All right. They want dr dt. What am I able to find? Well, what do I have? Let me lower this a bit first. Whoa, I didn't want to do that. Maybe if I make a smaller selection, I can do this. If not, I don't know what to do. Okay, there we go. So let's look at R. I know R, they told us that. So what am I able to find from that? I'm able to find dr d theta. That's what I'm able to find. So dr d theta would be -2 sine theta. But I want dr dt. So I'm able to find dr d theta, so I'm going to put that there to get my dr in the right place. How am I going to get d theta down there? Well, that's where this comes into place. Okay? So dr dt equals dr d theta. I want a dt on the bottom, so I can just wait a second. This is dr dt. Okay, this is so much easier than I realized. So if I find dr d theta, if I find dr d theta, it is dr dt. You see that? So I don't have to do anything. I just find dr d theta because they told me it's the same thing. But what is dr d theta? -2 sine theta. So I want to find it at pi/3. We didn't have to use a chain rule. They were so much nicer to us. dr dt at, dr dt equals, okay, let me back up. I can do this. At theta is pi/3 equals dr d theta at theta equals pi/3 equals -2 sine pi/3. But the sine of pi/3 is going to be radical 3/2, which is negative radical 3 for my dr dt. Let me double check that. Okay, yes, so it's negative radical 3. Now the question says, find the value and interpret your answer in terms of the motion of the particle. Well, we know that R is decreasing, right? And I would also notice here, and you can double check this, but all my R's are positive at all these. And since all my R's are positive and R's are decreasing, that would indicate that the particle is moving closer. Since R is dr dt is negative, that means R is decreasing, meaning the particle is getting closer to the origin as time moves on at pi/3. It's going to change, and you can actually look. Where's pi/3? Pi/3 is somewhere around there. And if you look, it looks like the R there is longer, and it's getting shorter and shorter and shorter and shorter and shorter and shorter. But then it's going to get longer after that. So I would say since r is positive for my answer, since r is greater than 0, and that's a horrible and dr dt is negative, therefore the particle is moving closer to the origin at theta equals pi over 3. And that's how I would conclude that.